The colonization of Mars has been a cherished dream of mankind for many years. Once it was reflected only in science fiction, but now this dream is no longer a pipe dream. What's happening now on the Red Planet and how close are we to it? Watch our video. It's no secret that Mars has come under the scrutiny of scientists in the last decade, but in fact attempts to explore it were made in the early era of space exploration in the 1960s. At first, it was more competitive in nature. The United States and the Soviet Union tried to grab the palm and invested unbelievable amounts of money in space expeditions. Mars, along with the Moon and other space objects, also came under scrutiny and became a major space target. Many attempts were made to fly to the planet on both sides, but at first, they all failed. The craft failed to reach, lost communication, failed to enter orbit, or disappeared. In 1964, the first spacecraft to photograph the planet from the closest distance possible at the time was the Mariner 4. It took pictures from a height of 9,800 kilometers and transmitted them to Earth. These photos generated a lot of speculation about the nature of the peculiar channels on the surface of Mars, which some considered man-made irrigation systems. Some even argued about whether Mars is as uninhabited as we think. But the reality was more prosaic, and the canals proved to be nothing more than an optical illusion. It wasn't until 1971 that the 9th Mariner was able to orbit Mars and explore the planet and its two natural satellites, Phobos and Deimos, for a full year. The Soviet Mars 2 and Mars 3 were the first to reach the planet's surface. However, the first one crashed while landing, and the second one fell victim to a dust storm after landing and managed to work for only 14 seconds. The most successful of the first were the apparatuses of the Viking series, which have done an incredible job, taking about 50,000 pictures as part of the Martian program, which are still valuable for research. However, the desolate Martian landscape obviously cannot please with its variety, and these images only make the average person feel bored. But why was Mars chosen for study? The closest planet to us is Venus, but its environment is so aggressive that no technique can operate on it for more than 2 hours. All other objects, be they planets or their satellites, are at a much greater distance, while with the current development of technology, it's possible to reach Mars in 6.5 months, which by cosmic standards is nothing. Also, despite the harsh conditions, Mars is somewhat similar to our home planet. Yes, the average temperature on the planet fluctuates to around minus 63 degrees centigrade. The atmosphere is very low in oxygen, plus it does not protect the planet from solar radiation. But scientists agree that Mars is not doomed to be a lifeless desert forever because there supposedly could be underground water. Recent observations of shining clouds by the Curiosity rover, which consist partly of dry and water ice, also suggest the presence of water. The best time to travel to Mars is once every 1.5 to 2 years, when the planet is as close to Earth as possible. It's during this time window in July 2020 that as many as 3 research expeditions were sent to Mars. NASA built its newest rover, Perseverance, to scan and drill the Martian soil for signs of alien life. On February 18, 2021, the rover successfully landed on the surface of the Red Planet. On June 1, the rover began the science phase of its mission by leaving the landing site. Until recently, Perseverance was undergoing system testing and commissioning, as well as supporting Ingenuity Mars helicopter's month-long flight test. NASA's Perseverance rover aims to study the Jezero region to understand the geology and past suitability of the environment in the area. The team will identify and collect the most conclusive rock and sediment samples, which can be retrieved and returned to Earth for more detailed study during a future mission. Perseverance will also take measurements and test technology to support future human and robotic exploration of Mars. The mission plans to find out whether microbial life existed on Mars billions of years ago, and if so, therefore life is not unique to the planet Earth. As Chris McKay, a research scientist at NASA's Ames Research Center, noted, this would be an outstanding discovery. He said, "Right here in our solar system, if life started twice, it tells us some amazing things about our universe. It means that the universe is full of life. Life becomes a natural feature of the universe, not just a quirk of this strange little planet called Earth." Hope, or Al-Amal in Arabic, was the first spacecraft to be launched to Mars last summer and the first Martian development for the United Arab Emirates. The UAE's first Martian mission, Hope, successfully entered orbit around the planet on February 9, 2021. The spacecraft spent 2 months entering its final orbit between 20,000 and 43,000 kilometers above the planet. The orbit was designed so that the spacecraft's instruments could take a complete picture of the planet's atmosphere every 9 days to support studies of Martian weather conditions and how gases from the planet's atmosphere escape into space. HOPE is the UAE's first mission beyond Earth orbit, and the UAE is only the 5th organization to successfully launch a spacecraft into orbit around Mars, after the United States, the former Soviet Union, the European Space Agency, and India. Part of the mission was timed to coincide with the country's 50th anniversary this year. HOPE will record all weather changes on Mars to a degree that's not been possible before. It's a demonstration of how space exploration is becoming an increasingly international field. The Tianwen-1 automated interplanetary station reached Mars on February 10, 2021. The orbiter observes Mars from space, creating a detailed picture of the planet's atmosphere and weather using a set of imaging devices. The camera will capture high-resolution images of the planet. An infrared spectrometer will study dust, ice, clouds, water vapor, and temperature in the lower atmosphere. And the ultraviolet spectrometer will study carbon monoxide, hydrogen, and oxygen in the upper atmosphere. After a successful launch, Tianwen-1 launched a landing module with the Zhurong Rover, which landed on the Martian plain of Utopia on May 14, 2021, and has already transmitted its first selfies from Mars in early June. The robot is very similar to NASA's Spirit and Opportunity vehicles of the 2000s. There are cameras on the high mast to take pictures and help with navigation. 5 additional instruments will investigate local rock minerals and the general nature of the environment, including the weather. Like the current U.S. rovers Curiosity and Perseverance, the Zhurong rover has a laser tool to work with the rocks to assess their chemical composition. It also has radar to search for subsurface water ice, a capability it shares with Perseverance. A total of 4 automatic stations on the surface and 8 artificial satellites in orbit are currently working on Mars. Where is Elon Musk and his Twitter and passionate tales of Mars exploration in all of this? Elon Musk has been dreaming about Mars for years, and as Starship turns into a working rocket, he is getting closer to his dream of landing on the red planet. SpaceX's goal is to launch Starship to Mars with a payload in 2022, followed by a manned flight in 2024. But that's not all. Musk wants to terraform Mars so that human society can thrive on the surface without spacesuits and airtight domes. But what does Elon need to change to make Mars Earth 2.0? Because Mars is farther away from the Sun, it receives less light and therefore less heat than we do. This means that the Sun in the Martian sky shines 40% dimmer than on Earth, making the planet noticeably colder. Cold temperatures are a side effect of the size of Mars, which is only 80% the diameter of Earth, and Mars is 10 times lighter. Smaller size means less gravity, only 38% of Earth's gravity. This will adversely affect any permanent settlers, especially developing children who need the extra gravity to develop healthy bones, muscles, and circulatory systems. The boiling point of water on Earth is 100 degrees centigrade at 1 bar or atmospheric pressure at sea level, compared to 0.006 bars on Mars. As a result, the boiling point of water is so low that water can only exist as ice or steam. Any liquid water outdoors would simply boil away, even at low temperatures. This means that if you were standing on the surface of Mars without an airtight suit, your body fluids such as blood, tears, and sweat would boil away, rupturing your veins and leaving you as a dry, frost-bitten husk. But there's much more waiting for you on the surface of Mars, even if you do wear a spacesuit. In such a thin atmosphere, with no magnetic field and no ozone layer, the surface is bombarded by radiation. On the surface of Mars, you get 30 to 60 units of radiation per hour. For comparison, we experience 0.00027 units of radiation per hour on Earth, which means 220,000 times more radiation on Mars. If you spend any reasonable amount of time outdoors, even in a thick spacesuit, you'd get a radiation dose sufficient for a significant risk of cancer and even nervous system damage. The combination of low pressure and radiation has another terrible effect. Many life-critical compounds are unstable and disintegrate in this environment. The building blocks for life literally break down on the surface, making life outdoors extremely difficult. As for Martian soil, it is full of perchlorate salts. This means that almost no plants can survive in raw Martian soil, And even if you filter out the toxic parts, there won't be any nitrogen compounds left in it that plants need to grow. But this soil is deadly not only to plants, but also to you. Mars regularly has global dust storms. The loose and fine dusty topsoil rises into the air, and if you breathe it in, it could be one of your last breaths. Elon Musk and his team are actively working to solve all these problems, but it is clear that this will require multi-billion-dollar investments and tens or even hundreds of years to transform the Martian surface and atmosphere for human life. So it is unlikely that Elon is destined to see the time when human civilization will flourish on the new planet. Perhaps the transformation of Mars will be humanity's greatest challenge, but at the same time, it could be a time for great accomplishments and even the transformation of humans into a new form to adapt to the Martian environment. Hopefully, future generations will live in a time when traveling or even moving to Mars will be something ordinary, and humanity will begin to think about other even more ambitious space goals.